Okay, this is induction type 1, the series 1. Second question, 1 plus 4 plus 7 plus 10 plus 3 times n minus 2 is equal to n over 2 times 3 n minus 1. So look, you need to put in n equals 1 and prove it's true for n equals 1. Then we put in our assumption. This is our assumption, so you can stop the video here while you do that. Then you put in what you have to prove, it's here in red. And then we start our proof here with our assumed. Okay, so we're down here to our assumed. So all I'm going to do is make the left side of my assumed look like the left side of what I want to prove by adding on the next term. 1 plus 4 plus dot 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 plus 3k minus 2, and add on the next term after that. So you want where k is k plus 1. So 3 times k plus 1 and then minus 2. Okay, and that's equal to the right side of what I assumed, but because I added on that blue bit onto the left, I have to add on that blue bit onto the right. So plus 3 times k plus 1 minus 2. Okay, off we go. So I'm going to rewrite my left side one more time so it looks exactly like what I have to prove. So I'm just going to skip all the way to the last term. I don't have to include the 3k minus 2. It's still there, but I don't have to include it. So 3 times, oopsie daisy, 3 times k plus 1 minus 2 equals. So now that's the same as the left-hand side of what I have to prove. So now I just need to make the right-hand side of my assumed into the right-hand side of what I have to prove. I need to get it, as you can see, 2 is dividing all of this side here, so I have to get it all over 2. So that's just going to be k times 3k minus 1. It all needs to be over 2, so that means this needs to get multiplied by 2 to put it over 2. So 2 times 3k plus 1 minus 2. Okay, so I don't have to rewrite the left side every time. So when I multiply that out, I'll get 3k squared minus k. And when I multiply all this out and tidy it up, I'll get plus 6k plus 2. And that's all over 2. Tidying up the top, might get my quadratic, 3k squared plus 5k plus 2, all over 2. And then finally factorizing that. Now, like factorizing, you use your root method, you can go through your minus b in your rough work and then reverse the end of it to get your factors. It doesn't really matter how you do it, but whatever way works for you. So I'll end up with k plus 1 multiplied by 3k plus 2 all over 2. So how are we doing? So we need to get to this. So I have my k plus 1 and I have my 2, so I'll pull that out to the side. So I've got my k plus 1 over 2, that's perfect. So now I'm just left with this piece here, and I need to adjust that. So 3k plus 2 needs to look like this, 3 times k plus 1 minus 1. Is that the same thing though? I bet you it is. So on my rough work, I'll probably just multiply that out, which is 3k plus 3 minus 1, which is 3k plus 2. Yeah, okay, so that is the same as 3k plus 2. So I'm just going to be cheeky and rewrite it. 3 times k plus 1 minus 1. Sure, who's going to argue with you? 3 times k plus 1 minus 1. Okay, so it's true for n equals k plus 1, true for n equals 1. So therefore it's true for n equals 1 plus 1, true for n equals 3, etc. Hence it's true for all n.